Okay, so today we are going to start with the sources of organic compounds. In the last class, we have ended with the isomers. So if just for a recall, isomers are those compounds having a same molecular formula, but possessing a different structures. So those are called isomers. So when we look into the resources from where we can get the organic compounds, so the major resource is fossil fuel. If we further discuss fossil fuel, so we can categorize fossil fuels into three: coal, natural gas, and third one is crude oil, which is also called petroleum. So basically, coal contains carbon in it. So beside coal, the next two, the natural gas and the crude oil, are the one which contains organic compounds in them. If we talk about a natural gas has a methane as its major constituent, a simplest alkane, a CH4. Beside methane, ethane, propane, and butane. If you recall the molecular formula, ethane is C2H6, propane is C3H8, and butane is C4H10. So these three compounds, along with the methane, are the constituents of natural gas. When we talk about a crude oil is basically a mixture of a hydrocarbon which contains compounds having carbon and hydrogen only. So, crude oil as a whole is not useful in its raw state. It is because there are so many compounds in it. So we have to process it, and after processing, we can separate it into multiple or many fractions, and those fractions are actually becomes the useful products which can be used for different purposes. Is this understandable to all of you?
Yes.
How we do the separation of the crude oil into different fragments? For that, we do fractional distillation of a crude oil, and that's is actually done in a oil refineries. So that's why it's occur on a large scale. Read this quickly, then we'll proceed further. Are you guys done? Okay. So this fractional distillation, we have already discussed it in experimental chemistry as well. In fractional distillation, we heat the petroleum or a crude oil, and then we allowed it to enter into the fractionating column, which is also called fractionating tower as well, and which is a very long tower from the bottom to the top. And at the top of this column, there is a very low temperature, and at the bottom, the temperature is very high. And due to the high temperature, or due to the temperature over there, the uh, liquid, the crude oil, starts to evaporate. and it starts to, separate due to the different boiling points. The ones having a low boiling points will start to rise up and up and up, and at the top they got condenses where the temperature gets lower than their boiling point. So they got condensed, they turns into liquid back and collected from there. The ones with the higher boiling point, they are collected at the bottom of the fractionating column, and the one which having a moderate boiling point will be collected at the middle of the fractionating column. So that's how they separated from the uh, from each other in the fractionating column due to the difference in the boiling points. Is this understandable? So usually we ask the question to explain or line out the process of the fractional distillation of the crude oil. So we usually write these uh, points over here.
Assalamu alaikum, sir.
Walaikum assalam. Yes, are you guys done? Now, you have to understand the trend and know the trend of the fractions when you are moving from the bottom of the fractionating column to the top of the fractionating column, how the properties of those fraction changes. So when we are moving and the fractions which we are collecting from the top as compared to the bottom, they have a lower chain length. The ones which are collected at the top having a smaller chain length, and the one which are collecting at the bottom having a higher chain length. Okay. Then they from bottom to the top, when we move from the bottom to the top, the volatility of the compounds becomes high. What does the volatility means? How readily they evaporate. How readily they evaporate. For example, if you look at a petrol, if you keep the petrol in open air, it readily evaporate. But if you put the diesel, it doesn't evaporate like that, right? So it means that diesel have a longer carbon chains and the petrol have a smaller carbon chains. Okay. Then as we move from bottom to the top, the boiling point also decreases. And that's why they become more volatile because they have a low boiling point. So they can easily evaporated or boiled at higher temperature. From where I shall just, yeah, sure. From here, okay. Then from bottom to the top, when we move, they becomes their volatility, their viscosity decreases. They become low, less viscous. What does a viscosity mean? Can anyone know? Yes, Laiba.
Sir, resistance like dense.
Very good. It's a resistance in a flow of liquid. That how liquid flows, how readily it flows, it means it's uh, if it flows more readily, it has a low viscosity. And if it flows slowly, then it means it is more viscous. Is this understandable? So these are the trends of the fragments or the fractions which we got from the bottom to the top. The trend in their properties, their chain length decreases from bottom to the top. They becomes more volatile from bottom to the top, means they evaporate more readily. Their boiling point decreases from the bottom to the top. Their viscosity decreases from the bottom to the top. Is this understandable? Yes, if any one of you have any confusion or any query, please ask. Okay. Then you have to know these fractions and their uses. So these fractions are like this, that from the top to the bottom, the fractions that we got from the fractionating column in the oil refinery. So from the topmost space, we got a refinery gas, which is used in the cooking and heating. Then lower than it, we collect the petrol or the gasoline is collected, which is used as a fuel in car. Then lower than that, we collect naphtha fraction, which is a chemical feedstock, which means which is a raw material for some various chemical industries like cosmetics, pharmaceuticals, textile, and other chemical industries. Then we have a lower than that, we have a kerosene or paraffin, which is used as a jet fuel. Then lower than that, we have a diesel oil, or it's also called gas oil, which is used in the diesel engines for a fuel. Then we have a fuel oil. That fuel oil is basically used in ships as a fuel and in our home heating systems. Then we have a lubricating oil, which are used as a lubricants like waxes and polishes, or the engine oils that we used in cars. And the last one is a bitumen, which is very thick liquid and used to make roads. No, Saad, low viscosity means it's have a lower resistance in flow, so it flow faster. And high viscosity means it have a higher resistance in flow, so it flows slowly.
Hello.
Yes.
Sir, high viscosity जो नीचे वाली
Yes, the one
high
which at the
viscosity
bottom are
मतलब
having a higher viscosity, so they flow slowly, right?
yes.
Saad, is this clear to you as well?
Yes, sir.
Everybody done? Now, as we have discussed, the hydrocarbons are those compounds which have a carbon and hydrogen only, right? So it means CH4 is a hydrocarbon, C2H6 is a hydrocarbon. Let's say C2H4 is also a hydrocarbon. C3H8 is a hydrocarbon. C3H6 is a hydrocarbon. But if you compare these two, there is a difference of a hydrogen. And if you try to, uh, apply the general formula. So it has a general formula of CnH2n plus 2, which is of alkane, and it has a general formula of CnH2n, which is an alkene. A difference is that in this compound, all the carbon has a all single covalent bonds, and here the carbon has a double bond, right? So we have a two categories of the hydrocarbons. One are called saturated hydrocarbons. So saturated hydrocarbons are those in which carbon are forming only single covalent bonds to each other. So the compounds like this in which there is a no double bond between the carbon atoms, all the single bonds exist between the carbon atoms are called saturated hydrocarbons. Is this understandable? And that's why we call it saturated, because if you look at each carbon, so each carbon is bonded to four different groups. Like over here, something is bonded, over here, something is bonded, over here, something is bonded, and over here, something is bonded. So no more group is going to be added in it. So that's why they are called saturated. They have a no space for any other group to be added in it. Then we have a unsaturated hydrocarbons. If you look at unsaturated, so the ones which have a space in the structure to add some other substance or other element in them. So those are called unsaturated. So unsaturated are the ones which have a carbon-carbon double bond. So see, if I look at this carbon is bonded to three groups instead of four, 1, 2, and 3, right? So it can add one more group can be added in it. So that's why they are called unsaturated hydrocarbons. Is this clear to all of you? Yes, everybody done? So you have to remember saturated with all single bonds and unsaturated with a carbon-carbon double bond. Yes, done. Okay. Now we have discussed about the molecule general formula of the alkanes, how to make their molecular formula, then structured formula and displayed formula. All the things we are done. So we are just going to review those. That alkanes are the structures where the carbon has a single bonds. They are saturated hydrocarbons, which means there is no other element but carbon and hydrogen. The general formula is CnH2n. The first four members of the alkane are gases like methane, ethane, propane, and butane. These all four are gases. Then there are liquids. And from where we can get alkanes, we get alkanes from the petroleum. Now the chemical reactions of alkanes, what chemical reactions alkanes undergo? So alkanes undergo three type of chemical reactions. One is cracking, the second one is combustion, and the third one is substitution. Remember that alkanes are least reactive among all the organic compounds. So in cracking, what we do or what the reaction is basically a long chain hydrocarbons or the long chain alkanes are broken down into smaller chain alkanes and alkenes. So whenever a compound or very long chain is broken down, it will give you a small chain alkane, and along with that small chain alkane, a small chain alkene is also formed. And sometimes along alkene and hydrogen gas is formed instead of forming of alkane. So there are two possibilities. Either you get alkanes and alkenes, or either you get alkenes and hydrogen. For this reaction, the absence of oxygen is mandatory. It's very important. Otherwise, if oxygen is there, then instead of cracking, combustion occur. So we have to, if we have to avoid combustion and do the cracking, oxygen must not be there. And further, we need a catalyst. We use a catalyst over there to speed up the reaction, but still a high temperature is needed to maintain for a cracking to occur.
Sir, do we need to mention the catalyst?
No, but there is the catalyst that usually we use over here is either silicon oxide or aluminum oxide, but it is not
And,
mandatory. It is that you must know the catalyst, but it's not necessary every time to mention it. If the examiner asks you, then you have to.
and pressure?
No, no need of pressure. Yes. It's done. Okay. So sometimes examiner ask you why do a cracking is important or what's the reason. So basically, when we do the fractional distillation, the fractions that we obtained having a smaller molecules are in a lesser amount, and the fractions which we obtained having a larger or longer chain molecules are in the larger amount. But as the need of our industry is that industry needs more number of our smaller molecules, that its demand is very high because they are very useful as compared to the longer chain molecules. So the longer chain molecules are not as useful as much as they are obtained. So to meet the need of the industry, we do cracking and make the longer chain molecules into the smaller chains. So the need of the industry must be, fulfilled. So that's why we do the cracking. Okay. So now have a look at the equation. So one equation, as I have told you, that long chain alkanes on cracking form one small chain alkane molecule and one small chain alkene molecule. See, we know the general formula, so it's very easy to make the equation and if we know which molecule or which long chain compound we are cracking. So obviously, if it's a 10 carbon alkane, so according to the general formula, we got the number of hydrogens. Now, if you crack this one, there are so many different possibilities of an alkane and alkene because there are 10 carbon. So if you see, I made one equation having 5 carbon atoms each in one alkane and an alkene. So I use the general formula to make these compounds. Then It's up to you. If the examiner didn't mention any one of the product and ask you just to write the equation for the cracking, so you can make any two, al one alkane and alkene. For example, here I make alkene of a 8 carbon atoms and alkene of a 2 carbon atom. So instead of these, I can make like this as well, C7H16 and C3H6. Okay. Or instead that I can make an alkene of a 4 carbon atoms like C4H10 and alkene of a 6 carbon atom C6H12. So if examiner didn't mention any one of the product, and if the examiner mention any product, then you have to follow that, and you may have to make the other product according to the one which examiner mentioned. And the other equation that sometimes on cracking alkane converts into alkene by releasing the hydrogen. So have a look. Usually it occurs when we have a smaller chain alkanes like this C2H6. So from this, 2 hydrogens has been released from the 2 neighboring carbon atoms, making a hydrogen gas, and those 2 carbon atoms bonds with each other, forming a C2H4. It's like this. For example, if I show the displayed formula, all of these 3 positions, there are hydrogens, and on cracking, from one position, hydrogen is released from each carbon, and those 2 hydrogens join with each other to form H2. Is this understandable? Okay. Complete it till here. Then we have a combustion. Then, okay. So combustion is basically a chemical reaction in which a substance reacts with the oxygen or it reacts with the air. That is called combustion. Okay. So organic compounds do 2 type of a combustion. One is called complete combustion and the other one is called incomplete combustion. So, okay. So the difference is that when we talk about a complete combustion, it occurs in excess air or if there is a excess oxygen. And if there is a limited air or oxygen, or it's the combustion is taking place inside the car engine, then it's an incomplete combustion. The only difference is the products that formed are different. When there is a excess air or oxygen, or if there is a complete combustion, then the products formed are carbon dioxide and water when we do the combustion of alkanes or hydrocarbons. Okay. And if the hydrocarbons are undergoing incomplete combustion or undergoing combustion in a limited oxygen, then we got carbon monoxide and water as a product. And sometimes there are black soot are also formed. And if the examiner use the term black soot, it means there is a solid carbon which is formed over there. Okay. So completed till here. And from here onwards, we will continue in our next class. Yes, Mustafa?
सर मैं बोल रहा था हमारी ऑर्गेनिक कब तक खत्म हो जाएगी?
I'll going to take 2 classes on this weekend as well. So hopefully by next Tuesday or Thursday we'll able to finish it.
सर मैं मिनिमम कितने पेपर करूं? I mean मैक्सिमम.
maximum you can go till